My dear students, welcome to DM Pannade classes YouTube channel. Now let us discuss about types of functions. We know that already we studied about functions in first PUC relations and functions chapter. Now we will discuss about types of functions, their definitions and examples. Okay. Here we consider a function f from x to y. F from x to y is defined to be 1 1 or injective or injectivity or injection. If the images of distinct element of x under f are distinct. This is definition for 1 1 function. That is for every x 1 x 2 belongs to x domain of a given function x, f of x 1 is equal to f of x 2 implies that x 1 is equal to x 2. This is mathematical definition for 1 1 function. Otherwise, f is called many one function. Otherwise, f is called many one function. Okay. My dear student, this is the standard definition for 1 1 function. Okay, 1 1 function. Okay, here we observe that the function f 1 and f 4. My dear students, please observe f 1 and this is f 1 and f 4. Look here, x 1 is the pre-images and x 2 are the images. 1 is associated with A and 2 is associated with B and C is associated with D and 4 is associated with C. Okay. Here in this case, in first figure, A is the image of 1, B is the image of 2, C is the image of 4 and D is the image of 3. Okay, here because of this, this is the this visual representation shows that f1 is 1 1 function. f1 is 1 1 function. Okay, here my dear student, please observe figure number 2 f2 function. Okay, here B is the image of B is the images of 1 and 2 because of this f2 is not 1 1 function. Okay. Similarly, we observe f3 function. In again same A is the images of 1 and 2 because of this f3 is not 1 1 function. Okay. My dear students, please observe figure number 4. Okay. This is 4 f4 function. 1 is associated with B and 2 is associated with C and 3 is associated with A and 4 is associated with D. Okay, here if the images of distinct element of x under f are distinct because of this f1 function, f1 and f2, f1 and f4 are 1 1 function and remaining f2 and f3 are not 1 1 function. Okay. This is some information about 1 1 function. Okay. 1 1 function or injectivity or injective or injection. Okay. Next, second definition, next function onto function. Okay. Next, f is a function f from x to y is said to be onto function or surjective function if every element of y is the image of some element of x or all the elements of x under f. This is definition for onto function. Okay. Okay, here we okay, this is definition for onto function or that is for every small y belongs to y We consider small element y belongs to codomain of a given function f, then there exists an element x in x. There exists an element x in x such that f of x is equal to y. F of x is equal to, this is definition for onto function or surjective or surjectivity or surjection. Okay. Okay, here again we observe f1, f2 and f4 functions. Okay, we observe that this function. Okay, here the definition says that every element of y. Okay, here we consider this is x and this is y. Okay, every element of y is the image of some element or all the elements of x. This is definition for onto function. Okay, here in y, e and f are not images, because of this is not onto function. Similarly, we observe that in f2 function 1 e and a, e and f are not images because they have don't free images. Because of this f2 is again not onto function. Dear students, please observe f3 and f4 functions. This is f3 and this is f4. Okay, here a is the images of 1 and 2, b is the image of 3 and c is the image of 4. Because of this is onto function. Okay. Similarly, we consider f4 function. A is the image of 3, b is the image of 1, c is the image of 2 and d is the image of 4. Because of this, the every element of y is an every element of y. Okay, here in y all the elements are images because they have pre-images. Because of this is one onto function. This is some information about 1 and onto functions. Okay, here next this remark is very important for solving examples on onto function. Okay, remark says that f is a function from x to y is onto if and only if the range of f is equal to y. The range of f is equal to y. Y is the codomain of a given function. Okay, this is codomain. This is exactly is equal to range of f. Okay, here suppose in any function a range of f is equal to y, then we say that f is onto function. Otherwise, f is not onto function. Okay. Next, suppose sorry. Sorry for the disturbance. Okay, wait. Okay. The range of f is equal to y, then the given function f is said to be onto function. Okay. Next, the function f from x to y, is said to be 1 and onto or bijective if f is both 1 and onto. My dear students, the given function f must be 1 and onto, then that function f is called bijective function or 1 function and onto function. Okay. This is the some information about bijective function. My dear students, the given function f is both 1 and onto, then that function f is called bijective. Okay. Next, discuss discuss some examples on 1 function and onto function. Okay, 1 function and onto function. 1 function and onto function. Okay. Next, show that the function f from n to n. The domain is set of natural number and codomain is again set of natural number. F of x is equal to 2x is 1 but not onto. Okay, here in this case our aim is to show that f is 1 but not onto. Okay, solution. f is one function, f is one function for f of x1 is equal to f of x2. F of x1 is equal to f of x2. Okay, here put x is equal to x1 in given function, we get f of x1. Again put x is equal to x2 or replace x by x2 in given function, replace x by x2 in given function, we get f of x2. Then put f of x1 is equal to and f of x2 is equal to, we get 2x1 is equal to x2 and 2 get cancelled, we get x1 is equal to x2. This result shows that x1 is equal to x2 shows that f is one function. Okay. Next prove that wait. Next prove that f is not onto function, f is not onto function. Okay, f is not onto function. Okay. Here we consider 1 belongs to codomain of a given function n, then there does not exist in n such that f of 2x is equal to 2x is equal to 1, 2x is equal to 1, 2x is equal to 1. Because of this f is not onto function, or okay, this is the solution of this example. Okay. Next move on to next example. Prove that the function f from R to R given by f of x is equal to 2x is 1 1 and onto is 1 1 and onto. Okay. The domain of this function is R, the codomain of this function is capital R. Because of this function is 1 1, f is both 1 1 and onto. Okay. Next f is 1 1 as f of x1 is equal to f of x2. Just replace x by x1 in given function, we get f of x1 and replace x by x2 in given function, we get f of x2, and f of x1 is 2x1 and f of x2 is 2x2. Okay, here this 2 and 2 get cancelled, we get x1 is equal to x2. x1 is equal to x2, this result shows that f is 1 1 function, f is 1 1 function. Okay. Next prove f is onto function. Given any real number small y in codomain of a given function R, then there exists y by 2 in R, because here we consider y is equal to or 2x is equal to y, 2x is equal to y and x is equal to what? X is equal to y by 2. Okay, y by 2. Then there exists y by 2 in R. Just put replace or put x is equal to y by 2. Then after simplification we get this 2 get cancelled, we get again y. Hence f is onto function. F is onto function. Okay. The domain and codomain of the given functions are a real number. On this function, f must be bijective function. It means f is 1 1 function and f is onto function. F is onto functions. Okay. Next move on to next example. Show that the function f from n to n, f from n to n given by f of 1 is equal to f of 2 is equal to 1, f of 1 is equal to f of 2 is equal to 1 and f of x is equal to x minus 1 for every x is greater than 2, for every x is greater than 2 is onto but not 1 1. Okay. In this case, our aim is to show that the given f is onto but not 1 1. Okay. F is not 1 1, f is onto. Next, f is not one function because of this. Because f of 1 is equal to f of 2 is equal to 1. Okay, here the images of 1 and 2, the images of 1 and 2 having same, that is 1. Because of this, f is not one function. F is not one function, but f is on 2. But f is on 2. Okay, but f is on 2. As given, any small y belongs to codomain of a given function n, y is not equal to 1 because y is not equal to 1. We can choose x as y plus 1. It means we consider this is equal to y, this is equal to y, okay, and express x in terms of y. Because of this, x is equal to y plus 1, such that put x is equal to y plus 1 in given function, then after simplification we get this plus 1 and minus 1 get cancelled, we get f of y plus 1 is equal to y. Okay. And therefore, because of this, f is onto function. Okay. Next example, show that the function f from R to R defined as f of x is equal to x square, is neither 1 1 nor onto. It means R is not 1 1, R is not onto. Okay. F is not 1 1 because of this, f of minus 1 is equal to f of 1 is equal to 1. Okay, here 1 is the images of both the elements minus 1 and plus 1. Because of this, f is not 1 1 function. Also, we consider small y is equal to minus 2 in codomain of a given function R. R is not the image of any element in X in the domain of R. Because of this, f is not onto function. Suppose we consider y is equal to some positive real number, then in that case f is onto function. Otherwise, because of R is not onto function. Okay. Thank you, my dear students, watching this video.